What's up, guys? We are back again looking at GPT Neo, the open source implementation of GPT-3 ADA. Today specifically, we're going to look at the performance impact of running on a GPU versus running on a CPU. As I mentioned last time, you can run the large model on any GPU that has roughly greater than 13.5 gigabytes of VRAM, and you can run the smaller model on a GPU with any GPU above roughly 7.5 gigabytes of VRAM. And of course, by large model, I mean the 2.7 billion parameter model, and for the smaller model, I mean the 1.3 billion parameter model. There is a chance you can get away with using a GPU that has a slightly lower amount of VRAM. However, with these numbers, I can say with good confidence you can do almost any inferences on the GPU. But as I made clear last time, both these models can run on a CPU, so what's the point in investing in a high-end GPU for these type of models? That is indeed the $1 million question, or rather the $2,000 question in the case of an RTX 3090. I'll go ahead and say that a GPU will perform much faster than a CPU when it comes to these models, but for the rest of the video we'll explore just how much of an impact it actually has. In this video, we're going to measure two different time measurements. First, we're going to measure the amount of time it takes to fully load the model into memory. And second, we're going to measure how long it takes to make an inference once a model is loaded into memory. To do this, we're going to do several runs through the notebook and run the notebook till we get to this prompt section here. Each of these runs will be clean runs, meaning nothing will be loaded into memory when we start the run. At the point in the run when we get to the prompt, that means everything is loaded and we can begin starting an inference if we wanted to. What we will be measuring is the one-time upfront cost to load a model either to the CPU or to the VRAM on the GPU. So let's get started. We'll first start out by testing the GPU load time. To do this, we are going to restart the kernel and run through everything automatically using this button here. At the same time, I will be having a clock here that will allow us to track the time it takes to load the model. So now let's get started with the first test, that test being loading the model onto the GPU. Once we get to the prompt section here where we can enter any text we want, we will stop the clock, as at that point the model will be loaded completely. As we could see, it took roughly 35 seconds to completely run through the notebook and load the model onto the GPU before we got to the prompt. This means that the model is now loaded and we can do inferences and use the model. Let's now do the same thing, but this time only run it on the CPU. To do this, I'm going to temporarily add an extra 0 here and here. Since my GPU has 24 gigabytes of VRAM, this will cause these if statements to fail and lead to this else statement, meaning we will not be using CUDA, meaning we will not be using the GPU to hold the model and hold the inputs. So now with those changes, I will go ahead and hit the restart button and start the timer. As you can see with the timer, that took roughly 32 or 33 seconds. A small but definite difference when compared to the GPU. This slight speed up is likely due to the fact that the model does not need to be moved to the GPU from the CPU. It is important to remember though that this is a one-time cost. In any application that uses GPT-3, we will likely keep the model loaded into memory. Let's now move over to the second test, that is, seeing how long it takes to use the model to actually make predictions on a given prompt. Since we already have the model loaded onto the CPU, let's do that test first. Let's do a simple prompt, and we'll keep the prompt the same for both the CPU and the GPU test. What is the meaning of life? And let's also have the output be the same. Let's do 200 tokens for both. Upon hitting enter for this input, the model will then start processing the input and generate an output. Again, I will have a timer on the screen so we can keep track of how long it takes. So let's get started. I'll stop the timer when the text is generated. As we can see, it took roughly 1 minute and 26 seconds for the output to be generated on the CPU. Let's now explore how long it takes to do the same thing, but this time on the GPU. To start, I will go up and revert my changes that I made to this if statement. So now the code will check to see if a capable GPU exists. On my computer it does, and the model and the inputs will be moved to the GPU for processing. So now let's again reload the kernel and run through all the code till we get to the prompt. So now the model is loaded onto the GPU. Let's go ahead and give it the same input as last time. What is the meaning of life? And we'll do the same length as last time, 200. Again, like last time, once I hit enter, the processing on the model will begin. And during that time, I will set a timer and we'll see how long it takes. Okay, here we go. And it's already done. As we can see, that was at most 5 seconds, probably closer to 4 seconds. Regardless, let's just call it 4.5 seconds. If we do the math, we had 1 minute 26 seconds for the model on the CPU, so we had 86 seconds. And let's divide that by 4.5. And we get a factor of 19.1 repeating. So as you can see, by having a GPU, we almost get 20 times faster responses from our AI model. These faster response times, when we have a large amount of users using our service, or when we want a service that is a more real-time service such as a chatbot, are very important. Even with our near 20x improvement over CPUs, this is to say nothing about utilizing batch processing. If you are not as well versed in the machine learning industry, you may not be aware of what batch processing is. Batch processing is the process in which we basically add another dimension to our input, and what this allows us is to, in parallel, process multiple prompts at a time. In layman's terms, we can even further utilize the GPU by processing, let's say, 16 prompts at a time rather than the one prompt at a time that you see here. By utilizing batch processing, I would expect that our real throughput rate would be even much higher than 20x, probably closer to 30x. So yes, GPUs can be very expensive, but their benefits are very beneficial for this area. I hope you now have a better understanding of the benefits of using a GPU over a CPU for GPT-3 and for machine learning in general. And with that, I'm going to end today's video. Please leave any questions or comments down below. If you liked the video, please consider liking and subscribing, as I'm not yet done exploring this model and its many possibilities and use cases. Thank you for watching, and please have a great day.